Hi there, Algebra 2 students. Welcome back. I hope that expanding and condensing logs went well for you. Logs are kind of a tricky concept, but hopefully you're asking questions and you're getting answers to your questions. So what we're going to do today is we're going to go ahead and we're going to apply what we know about rewriting logs and expanding and condensing them, and we're going to apply this to now help us learn how to solve exponential and logarithmic equations. So you should have your note-taking guide in front of you, and we're going to go ahead and work through several examples. Here we have 10 total problems we're going to do today. And we're going to first start off with learning how to solve exponential functions. So the front page is having to do with problems where we are going to see our x variable in the exponent. Okay, so number one is just to kind of start us off nice and easy here. If we have an exponential function that has the same base, okay, we see both 2's in the base position, and if it's the same base, then we can simply set the exponents equal to each other. So I take the exponents of x and negative 3x plus 1, and I set them equal to each other. Okay, it's pretty simple. If they have the same base, bases are equal, then their exponents are equal. So then we solve for that, and we would maybe add 3x to both sides, so that would give us 4x equals 1, and then dividing both sides by 4, so x equals 1/4. Okay, and what's nice about these problems is you can check your work. So if you check your work, let's see here, 2 to the 1/4 power is equal to 2 to the negative 3 times 1/4 plus 1. Okay, so that's going to give us 2 to the 1/4 equals 2 to the positive 1/4. Okay, so it checks out. All right, now let's look at number 2. This problem is a little bit different because the bases are not equal. Okay, we have a base of 9 and we have a base of 27. What we want to do is we want to rewrite those bases so that they are the same, okay? So we want to write them as exponents. So I can rewrite 9, I can rewrite that as 3 squared. So 3 squared raised to the 2x is the same thing as saying 9 to the 2x power. And then 27, I want to rewrite that as an exponent, but I want to use a base of 3. And I know that 3 to the 3rd power is 27. So I'm going to rewrite that as 3 to the 3rd power raised to the x minus 1. Okay? Now, using our rules of exponents, we simply multiply these exponents together. All right? Now, we're going to have 3 to the 4x, which is equal to, be careful here because we need to distribute, so we're going to have 3 to the 3x minus 3. Okay? So then, now that the bases are the same, okay, we have the same base, that means that our exponents are now going to be equal to each other. So I'm going to just make an equation and set those exponents equal, and then solve. So maybe subtract 3x from both sides, and that's going to give us a value of x at negative 3. Okay? Let's try number 3 here. So let's see, we want to rewrite our bases as exponents, and we want the bases to be the same number. So if we look at the number 81, we could rewrite that as 3 to the 4th power raised to the 3 minus x. And how could we rewrite 1/3 with a base of 3? Well, I could say 3 to the negative 1 is equal to 1/3, and that is raised to the 5x minus 6. Okay? So now that now that we have the same bases there, let's go ahead and multiply our exponents. So we're going to get 3 raised to the 12 minus 4x, because I have to distribute. and then that's equal to 3 raised to the negative 5x plus 6 because I'm distributing. So now that our bases are the same, we can set our exponents equal. Okay, so 12 minus 4x equals negative 5x plus 6. So now we want to go ahead and solve, and maybe you want to add 5x to both sides, and what that's going to give us is 12 plus x equals a positive 6, and that means that x then would be a negative 6. Okay, so that would be our answer. Let's look at 4 here. Okay, so some of the exponential equations that you solve, you won't be able to easily rewrite them so that they have equal bases. So this is where the logarithms come into play. Okay, so what I want you to remember is that we can write a logarithm, or we can take an exponential equation and we can rewrite it as a logarithmic equation. Okay, so let's take the equation 2 to the x power equals 5, and let's rewrite it as a logarithm. So it would be log base 2 of 5 is equal to x. And now all I have to do is evaluate log base 2 of 5. So what we're going to do is we're going to use our change of base formula, and I'm going to change it to base 10, common log base 10. So x is going to be equal to log of 5 divided by log of 2. So grab your calculator and plug that in. And what you should get when you plug it in is 2.32. Okay? So that is the value of x that equals 5. And you can check your work. 2 raised to the 2.32 should equal approximately 5. Okay? It's not going to equal exactly 5 because we did a little bit of rounding, but it's nice to be able to check your work there. All right, let's move on to number 7. Again, we're going to, this one we're going to rewrite as a logarithm. Okay, so we're going to rewrite it as log base 7 of 15 is equal to 9x. Okay, now we want to solve for x, so let's divide each side by 9. Okay, so now x is equal to log base 7 of 15 all divided by 9. And in order to plug this into your calculator, we need to rewrite the numerator so that we have a common log. So let's just use common log base 10, and we'll rewrite it as the log of 15 divided by the log of 7, and that's all going to be divided by 9. Okay, I want you to grab your calculator and carefully try to plug this in because it can be kind of tricky. You might need to do it in a couple steps. And what you should get out is approximately 0.15. Okay, so if you're not getting that when you plug it in, please try again because it is important to figure out how to use your calculator to evaluate these logs. Okay, and let's look at our last exponential here, and we're going to solve for x. Okay, so the first thing we should do is add 7 to both sides. Let's isolate our exponent. Okay, so we're going to rewrite this. We're going to say 4e to the negative 0.3x is equal to 20. Okay, adding 7 to both sides. The next step is going to be to divide each side by 4. So e to the negative 0.3x is equal to 5. Okay, now we will rewrite our exponential equation as a logarithmic equation. Okay, so since the base here is e, base e, we want to use natural log. Okay, so we're going to rewrite this as natural log base e of 5 equals negative 0.3x. And then the last thing we want to do is divide each side by negative 0.3. So x is equal to then natural log of 5 divided by negative zero point 0.3. So grab your calculator. I want you to throw that into your calculator and evaluate that. And what you should get is negative 5.36. Okay? All right, so now what we're going to do is we're going to move to the back side here, and we are going to look at solving log equations that have logarithms in them. Okay? So what you need to know here is that a logarithmic equation is going to have a restriction on the domain. Okay? So if you see here, there's this asymptote right here, and all logs are going to be greater than that value, right? So what that means is that this value of x right here, that can only be a number greater than 0, okay? So it's really important to check for extraneous solutions because sometimes some of your answers will not work, okay? And some tips here for solving logarithmic equations, you might want to rewrite in exponential form. That might help you. And you might want to do some condensing of your logarithmic expressions and then maybe rewriting them in exponential form. Okay? So let's look at example 7 here. Now example 7, because we have natural log base e on both sides, what we can do is we can simply set the quantities inside those parentheses equal to each other. Okay? So it's kind of like if we look back at that first problem we did here, if the bases are equal, we can just set the exponents equal. It's kind of like that. Okay? So if we have the same type of log, we can just set those expressions equal to each other to solve. So maybe you want to start by subtracting 2 from each side, okay? And then maybe adding 4 to both sides, so 5x equals 15, and then dividing by 3, so by 5, so x equals 3, okay? So then we want to get into the habit of checking for extraneous solutions. So we're going to take this value and plug it back up into the original problem here. We're going to check our work. So natural log of 7 times 3 minus 4 should equal the natural log of 2 times 4 plus 11. And we should not have any negative logs. In fact, they have to be greater than 0. So what we have is the natural log of 21 take away 4, which is 17, and that's a number greater than 0, so that's good. And the natural log of 8 plus 11, or excuse me, it's not 8. Why did I plug a 4 in there? I don't know. That should be a 3. It should be 6 plus 11, which is 17. Okay, so that is the same, and that works. Let's look at example 8 here. This is one where we want to rewrite it as an exponent in order to solve it, okay? So remember, again, we're going to rewrite it, which remember that if y equals b to the x power, then log base b of y equals x. So we're going to rewrite our log as an exponent, okay? So we're going to say 2 to the 5th power is equal to x minus 6. Okay? So then just evaluate 2 to the 5th power and then add 6 to both sides. So x equals 38. Okay? And let's go ahead and check our work here. So I'm going to plug in 38 into the equation. So log base 2 of 38 minus 6 equals 5. So log base 2 of 32 equals 5. And 2 to the 5th power is 32. So that works. Okay. All right, let's look at these last two problems. What we want to do first is the second tip there, we want to condense and then we want to rewrite. Okay, so if I'm adding two logs together, I'm going to use my product property like we learned in the last section, and I'm going to rewrite log of 5x times x minus 1 equals 2. Okay? So we've condensed it now, and this is so that we can rewrite it. We have to have only one log in order to rewrite as an exponential. Now, if we do not see a base, we're using common log base 10. So what we're going to do is we're going to rewrite as 10 to the second power is equal to 5x times x minus 1. So we have 100 equals, I'm going to distribute 5x squared minus 5x. Okay, this is a quadratic, so we need to set it equal to 0. So I want to subtract 100 from both sides. Okay, and now let's see if we can factor it. So the first thing we should do is pull out a 5. Okay, and that's going to give us x squared minus x minus 20. And now we can factor him into x minus 5 times the quantity of x plus 4. Okay? So the zero product property then says that our solutions are going to be positive 5 and negative 4. Okay? So we want to now check our work. So let's check positive 5. Okay? So checking, we're going to have log of 5 times 5 is 25 plus log of 5 minus 1 is 4 is equal to 2. Okay, so that is then, if we condense it, that's log of 25 times 4 is 100 equals 2, and that works because 10 squared is 100. So that one works. So that is a solution. Okay, now let's check negative 4. So log of plugging in negative 4 times 5 is a negative 20, plus log of negative 4 minus 1 is negative 5 is equal to 2. And this is not possible. And that's because we have negative numbers here. No negatives allowed. Okay? So negative 4 is an extraneous solution, and we're going to cross that off. Okay? So we have one answer, positive 5. Okay? So let's go ahead and do this last example here. What we're going to do is we are going to first condense. Okay? So let's rewrite it. We're going to say log base 4 of x times the quantity of x plus 12 is equal to 3. Okay? Now what we're going to do is we're going to rewrite it as an exponential. So we're going to say 4 to the third power is equal to x times the quantity of x plus 12. And then we are going to simplify and distribute. So 4 to the third is 64, and then that's equal to x squared plus 12x. Okay? Now again, we have a quadratic, so let's set it equal to 0 here. And now we factor. Okay? So we get factors of x plus 16 and x minus 4, which means that our answers are going to be either negative 16 and 4, 1, or the other, or maybe none of them. So we need to check our work. Okay, let's plug in the negative 16. So that's going to give us log base 4 of negative 4 plus log base 4 of negative 16 equals 3. And that is not good because, again, we have negative logs and we can have no negative logs, so negative 16 does not work. Let's check 4. So log base 4 of 4 plus 12 is 16, plus log base 4 of 4 should equal 3. Okay? So then if you condense those, 16 times 4 is 64. So we have log base 4 of 64 equals 3. And we're going to rewrite that as an exponential, and that works. Okay? So I want you to go ahead and get started on your homework for 7.6, and remember that if you have questions, you need to go and visit the Math Tutorial Lab in F107. I hope you have a great day, and we will see you next time for 7.7.